And uh, we're all set. And what I want to do is share with you first a project that I started when I was a high school teacher at Sohegan High School in Amherst, New Hampshire. And it's really just grew and grew and grew. It was a community science project. Still going, actually, and now I involve teachers with it at some field sites in Mexico. We can talk a little bit about that. So I'll talk about one that's very personal to me. And then I'm going to switch it over to a presentation just really about what citizen science, community science is all about. And from that, I'm going to share this. Those slides I borrowed from a good friend of mine, Karen Cooper, who is a University of North Carolina professor, and she wrote this magnificent book, Citizen Science, How Ordinary People Are Changing the Face of Discovery. And I'd love to talk to you a little bit more about her book, and I recommend this one highly, and we'll talk about that a little bit later. So, but I wanted to give some credit to Karen Cooper as well for the second half of this. So, HabitatNet. Okay, this was an idea that I had in 1995 to try to get kids outside and start collecting some baseline data on biodiversity. So this slideshow I normally use when I'm talking to teachers about biodiversity studies. I'm not going to be doing that as much with this. I'll be talking about the story of how it's really all about community science. So there are a couple of things I want to mention first about biodiversity. And I know Chrissy was asking me if am I going to be moving around a lot. And students that know me, I am kind of animated, so hopefully I don't go too far off. I'll take that with me. But biodiversity, simply put, is looking at the number of organisms found in one particular space. Most people would answer that if I asked them, but there are many other dimensions of it. On the slide I put down, it's also the variety of habitat that you have. It's looking at the genetic diversity within a population of species. And the last one I want to spend a little bit more time with, talking about biological phenomenon, is also a part of biodiversity. And right now, probably, if we stepped outside and looked up at this sky, we may see part of that phenomenon occurring right now. And that's looking at migrating nighthawks, which are really nightjars. So for the last couple of weeks, New Hampshire's been very fortunate to see this beautiful bird starting to wing its way south to South America. And for me, that's one of the beauties of studying biodiversity. Whoops, wrong way. Is that we begin to look at connectivity between different habitat. So one of the things looking at, so I get kids in my science classes in New Hampshire all excited about is we begin to take a look at those connections. Those birds we see in our backyard, where do they go during the winter? Okay, and look at habitat that they go in. Birds tend to be very faithful. So if we'd see them at our backyard feeder, chances are they're the ones that have been coming back there, descendants of generations coming back, and they go to that same spot somewhere in the tropics. So I wanted to mention that real quickly. And the last part is the one that gets me really excited. Right now, science has described about 1.7 million different kinds of plants, animals, fungi, protists. Sounds like a lot. They think, okay, it's estimated that there are probably 30 to maybe even 60 million species out there. So when you look at what we don't know, it's astounding. Okay, I mean, we're vastly ignorant of the species that we co-inhabit this planet with. And I think that's tremendously exciting. Okay, and I don't exaggerate when I say that that's something else we could do. We could go outside, dig up some soil, and find new species to science in that soil. Different nematodes, different worms that just haven't been described yet. Each year, there are about 4 or 5 new bird species that are discovered. About every 5 years, a new mammal species is discovered. Okay, so it's a very exciting field of study. So I just wanted to bring that up to give the backdrop for this. But as I mentioned, this was an idea that was actually founded on a napkin. I was at my wife's 20th high school reunion, thinking this is going to be a very, very boring evening for me. And she was very kind to introduce me to a friend of hers who's an entomologist living in Chiapas, Mexico. She and he were in the band together way back when. So I started talking to Bob about his experiences, and he was talking about a brand new reserve that was opening up in the Yucatan, and they were looking for research projects. Okay, all sorts of lights went off. And I was thinking this is an opportunity to get my high school kids involved with authentic research in the tropics. And so as I put in this slide here, since 1995, I've taken over 400 students and over 70 teachers to the reserve. 80% have survived, so I think that's pretty, no, okay. Brought them all back smiling, okay, no worse than the wear. So I know in today's educational mantra, there's a lot of talk about hands-on science, minds-on science. I usually talk about boots-on science, getting the kids outside. And I'm going to flip-flop between these two slides real quickly. For me, there were two goals. There were some education goals for starting this community science project and some pure research goals. So the education goals, and this is true for all sorts of community science projects that are out there, is it really democratizes what science is. It involves people with everyday studies to contribute in a way to their communities. So you begin to learn field methods, sample data, collect data, okay, and then you try to, as we say, kind of appreciate what that data is telling you. And for this particular project, looking at the biological diversity, it was collecting some baseline data both in Amherst, New Hampshire, where we were, and then also in Quintana Roo, Mexico. Second part, I don't know if there are any teachers online watching this or teachers here in the audience tonight, was my little secret. These student-initiated projects, okay? The overall arching question I use, how does disturbance influence biodiversity? And what we would do is we'd look at, as I put just in bold, the changes in natural processes over time, response to disturbances, both anthropogenic, man-made, as well as natural disturbances from fires, hurricanes, drought, we talk about this summer. And we developed some baseline data on that. So this little jewel, I'm a slow learner as an educator, came to me about 15 years into teaching. And what I wound up doing is I just created, just to kind of downsize, a very simple research design. Okay, and this is where I do move around a bit. Still hear me? Yeah. Okay. So what I used to do, that first week of classes with my students, Liz, one of my former students probably remembers, and Chrissy, is I'd take them outside, day 2 of school, and say, look for an ant and follow it. And don't come back for 20 minutes. Go follow an ant for 20 minutes. And they would look at me, okay, it was the new teacher of the year. This guy, is he crazy? What's he saying? Nope, go follow an ant. Come back in 20 minutes. And inevitably, they would come back with great questions about ants. And I would then say to them, okay, well, they'd want to know the answer. Why do they do this? Why do that? So that became the focus of their own research project. So what would happen is they'd have this question right up here, and then I'd get them to design a process to collect some data to try to answer that question. And what you could see in this next slide is oftentimes teachers would ask, well, how do you keep track of all these kids and all these different projects? So it was with the magic of sticky notes. So kids would have their names on the sticky notes, and they would self-assess where they were in the process of going around that circle. And this does two things. One, it gives me a great visual as an educator. And just looking at this, I would say, these kids are having trouble. They haven't moved. So I'd know where to focus some attention. These kids think they're finished. Are they really there? So I'd prioritize my time to check with those before kind of moving with the herd here. So it's a great way to do that. But the other thing that it does is for the individual kids. It actually got them to internalize the scientific process and the research process, because they'd have to reflect on where they were in each of these stages. So we're a curious species. So take kids into a forest, whether here in New Hampshire or in Mexico, Costa Rica, and get them to actually start measuring trees in a 20 meter by 20 meter quadrat. And we had a nifty little program that on the left you could see that is depicting a 20 meter by 20 meter quadrat with what you consider little dots. Those are individual trees within that 20 meter by 20 meter sample. And on the right, okay, it's just a listing of all those trees by species and what their diameter or breast height is. So this is very concrete. They're learning a field method, they're going out there, but simultaneously what's happening is they're looking at the forest, they're interacting with the forest, they're getting some questions, and those become their research questions. We would do, this is always the fun part, species inventories. So in Mexico, okay, I'm sure Liz probably remembers, some of you, the famous crocodile out there. We'd always go out to see her, Benita, okay, and she became quite accustomed to us from time to time, and would even be able to get her up close and personal, come up and take a look at her, and we'd measure her and see how she was doing. Wildlife studies, okay, were always a big hit with students. You could see, okay, that far left, students are actually making a plaster cast of some puma tracks. In the center, we have Beth, who's now a science teacher at Amherst in middle school, doing a herpetology project. Boys will be boys. These guys, I don't know what they were doing, just being mudmen out there. Bridget was actually collecting some ants. And I can tell you right now, she's a PhD entomologist. Okay, it was kind of inspired by that. And this is one of my all-time favorite students, Julia, right here. She was a juvenile spider monkey that moved in with us into the field station, one field session. And was she there when? No. Okay. So so the kids fell in love with her. This is great. We got a monkey living in our cabin. Okay, but what would happen is every time we'd go out in the field, Julia would go through their backpacks looking for candy and snacks that they brought. So this was modernized, but back in the late 90s, I was using the old style pre-digital film cameras, kind of game cams, getting pictures, and we were actually able to get the first photograph of an ocelot, okay, puma, and eventually jaguar as well. So this actually developed into a whole big project that's still ongoing. Now we have out at the reserve 40 different digital cameras. We've set them up across the trail from one another because the spots are unique to each jaguar. So we're actually able to count and look at the diversity of jaguars that are found, or at least use the reserve going through. So my little trade secret is I would bring cans of cat food with me. And I'd look for trails where it looked like cats were using from either their tracks or looking at their scat, AKA their poop. Okay, and I'd place some wet cat food there and then set the cameras up so they get a little snack as well. So this project really began to grow. The Smithsonian Institute really liked the idea that I was using armies of students to collect data. So they invited us to a couple of their sites. This is the little Dutch island nation of Saba in the Caribbean. Hurricane George really decimated their forest on Saba, and they invited me to bring a team of students 2 summers in a row to do an assessment, to take a look at the damage and make a prediction of how long it would take for the forest to come back. So this was an authentic project. The kids are actually collecting data, moving through, and we were kind of doing some assessment of it. I want to go, getting the kids to actually interact with some of the mathematics, looking at the importance values, looking at the Caribbean data over time. And I'm not going to spend a lot of time on this, but it was kind of interesting. It was good news for the island of Saba. If you look at disturbance in tropical forests, hurricanes, there's a lot of mechanical destruction, but all the material remains there. Vegetation, seeds stay. So the regeneration does happen. When we do it, anthropogenic, we tend to, if we're going in, we clear the forest for either cattle, horses, or other human needs. Okay, and that removes that biomass and also the seeds. So there's a significant time difference between recovery of forest to whether a hurricane or U.S. So a lot of fun with these kids. I like to, once again, getting them involved in their projects. I always put this in here just to mention. Kids in their field notes have got a bird that actually authenticated a field note out in the field. Okay, and this one I always tease my brothers who are both in the world of business. I tell them I like my office much better than theirs out there in the forest. Okay, so then what happened, started in 1995, this project was growing and growing, and in 2004, I talked with the director of the reserve, saying, what if we host a global symposium for kids at the reserve? His name was Marco Lascano. He loved the idea. And the reserve, okay, as any of you who are zooming in tonight, or Liz, who's there, know, has a maximum human capacity of maybe 20. And what happened was, when I put this out there on the website, starting in high school, started getting copied to other websites, I had 80 kids from 12 different countries apply to be a part of this. their applications were just so moving and inspired. I accepted them all. And I told Mark, I said, good news, it's going to happen. I said, the challenging thing is we're going to have 80 people there. And that became the question of how we're going to deal with the logistics. And I was just like, logistics are logistics. So we'll do it. And of course, some of the other things was I was helping students and teachers from countries get visas. That some of them needed it to enter Mexico. Had many different languages. Okay, and then working with the student teams months before, realized that all the students coming could either speak at least English or Spanish. So I made the decision that we were going to do the whole program with the students bilingually. And what we wound up doing to get things started with, I had 40 kids come for a week, and then another 40 kids come a second week, and then we did everything else online afterwards to get together. And the question I posed to the kids was, if you had to tell world leaders why saving biodiversity is important to your future, what would you tell them? We're going to work on a document and submit that to those world leaders. Not only different presidents, parliaments, but we also sent it to the United Nations Convention on Biodiversity. We'll talk about that in a minute. So kids came, and I landed in Cancun a couple of days before, went shopping in a Walmart there, getting some goofy supplies, art supplies, because I wanted to do kind of some games with the kids, kind of build community since they didn't know one another, and there were going to be some language issues. So great thought, get some face paint. I couldn't find any face paint in Mexico, so I thought, here's shoe polish. Why not? What could go wrong? Okay, a lot could go wrong. It doesn't come off that easily. So we had that. Kids were making different sculptures using chewing gum and a lot of different fun games to get them to get to know one another in a hurry. So during the mornings, we would work together out in the field, in the forest, collecting biodiversity work. These were our deluxe, 5-star accommodations. Okay, my wife went with me one time to the reserve, and she's proud to say that was the last time she would go to the reserve too with me. So, but my own children, 3 daughters, they've been there multiple times with me. So it's a great place. Okay, and you can see, just the finest, mosquito netting, everything you possibly could need. So it's completely off the grid, no cell phone service, no internet. So what I did with the students before coming to the reserve, I had them say, prepare a presentation. Talk about what you do for biodiversity back in your home country. And it was really, and I thought that would be our evening entertainment. Really great thing occurred, which I didn't even think about afterwards. The kids began to see that they had kindred spirits across the planet. Kids from different parts of the world that really were concerned about biodiversity. These kids are now obviously adults, and a lot of them are still keeping in touch, not only me, with one another. So the evenings we would have these presentations, and the kids would talk to one another about their projects. So worked on going through kind of like an arts literacy project with them of before the writing began, okay, building friendships, our wildlife studies. One of the research species I spent a lot of work documenting were bats, and of course there's bonita, or crocodile. And then I'll just get to this. So in the last couple of days, while we're in the forest, opened up the laptops, got the kids working on a document. As far as if they were planning on submitting to the United Nations and different world leaders. So that work was pretty earnest. Okay, at the end of 2 weeks, Marco, who's the director of the reserve, actually arranged for a press conference in which that second group of kids gave a report to the press in Cancun. And then we came home and we worked another couple of weeks online, really worked getting that document all together, and it was submitted to the United Nations as well as various governments around the world. The United Nations recognized it immediately. They invited me to bring some of the students to the convention headquarters, which is in Montreal, Canada, which the kids actually read it into the proceedings, and it was adopted by the United Nations in 2008. They then actually invited a COP, is what they call it, is the Convention of the Parties, at COP9 in Bonn, Germany. They also invited students back to make a presentation at that international conference. So it was really pretty cool to see these kids, talking about the work that they did in producing this policy document that actually was adopted by the UN Convention on Biodiversity. I promised my wife I would never again organize something like this again, because it literally consumed me for almost a year. And I had a friend in Ottawa, Canada, who worked with elementary school students, and he asked me to help him organize one for elementary age students in Ottawa, Canada in 2009, which we did. And that year too, we had something like, you can see on this next slide, participating countries of students that were coming. So, I just wanted to mention this, in the end, we can serve only what we love only what we understand, we'll understand only what we are taught. Baba Dayum was a Senegalese conservationist. So it's not really thank you, it's not over yet, okay? So I used, that idea of kids all smile in the same language, actually I'll talk a little bit about this at the end, a book I just wrote for teachers on this subject. So let me switch over to the other Karen Cooper presentation, talk a little bit in general about community science, and then open it up to questions and comments. Whoops, come here, come back. Are we good, Amanda? Yes. Okay. Oh. Okay, did I, there we go. No, I'm zipping along here, sorry. Okay, so once again, I just want to mention this next group of slides is compilations, some of which belong to Karen Cooper. She's allowed me to use some of hers and mix it in with a few of mine to really talk about. She's really an authority on what community science is all about, or citizen science. So I like to think about citizen science, which it's been known as really kind of a community science, because it does involve all the community. I'm not going to read through all of this, but I think what I get excited about is it really gets students to partner with scientists, think big, gives them a chance to use their innate curiosity and to get out there. It's collaboration. I did mention it's kind of the democratization of the practice of science. I'll talk a little bit more about that in a minute, where science sometimes could be seen just in the black box. What do these guys do? Well, this gets everybody involved as scientists. So, and I think if for looking at it from an educational standpoint, students get to share with an outside audience, which I think is very important. It's not just to their teachers. Students own the data, and they interact with the data. I think that's the key part. They're not just collecting data and sending it off. They're learning to be thinking and actually interacting with that data. And I always like to say for teachers, this doesn't supplant your curriculum. You could find whatever you're doing, whatever curriculum you're doing, you could find a project that actually enhances, what you're doing by getting the kids to collect data and interact with that. So I say, position students as people who do science. Students use real terminology, the tools, and they become fluent in it, and they even joke about it too. When they start joking about the skills that they've learned, you know that they've got it. So I think it's a very important kind of context for getting kids to become more scientifically literate. So there are different types of citizens projects. So don't worry, you don't have to take any of these notes. One, I am going to make these slides available, and I'll give you my email. I'll be happy to send it to anyone. Some can be contributory. Those are ones that are usually designed by scientists and get people coming in. It's like my HabitatNet project. I kind of design a biodiversity project, and we collect and share data. Some are collaborative, where they're structured by scientists with a lot of collaboration, usually looking at like a river watch project. There's some pollution in an area, that need different groups and communities to be involved with that, and some are co-created. So what I like, it's learning science by doing science. Students really begin to understand the scientific explanations. The second part I think is really important, is where they begin to generate the scientific evidence and interact with that. So I love this slide. Okay, these kids, former students of mine. Okay, I think what happens is that they find out science is really messy. Okay, answers aren't always there. And sometimes your data is zero, no data. And that in itself is real data. So getting them to interact with it and seeing those messy edges of science is what really kind of keeps them going. So what I want to do right now is, I've been yakking at you a lot. Okay, and I want to stop for a couple minutes, and I'd like to do a little turn and talk. So if you could kind of turn and talk to one another and answer this question: what do scientists do? I want to demystify the scientists. So spend a couple of minutes, talk to one another about what do you think scientists do. I'm going to ask you to say that in a minute, okay? Do we have a couple of people who would like to share? Okay, what's your name? Bethany. Okay, Bethany, what would you like to say? Okay. Right, and I wish people at home could see the enthusiasm and the emphasis Bethany put on the fact that scientists don't quit. They stay with it. Yeah. Other comments, thoughts? Yes. Colin.
They're trees. They learn new things, and they adventure.
Okay. Yep, they learn new things and they look for and participate in adventures. Yes. How many of you have been scientists at one time or another? Okay, look around. Yeah. I mean, we all have it in us, okay, to be scientists. And I think that's the fun part about community science is we get a chance to let that inner scientist out, okay, and get out there and ask some questions and move forward. So, little teacher point here. One of the things I would do in my classroom is I'd ask this question to my students: what do scientists do before we'd start any project? And we'd make a list. Okay, and then after we'd do a project, we'd come in, I'd ask the students to look at that list and to think about how they were doing some of that, to just reinforce that we all can be scientists. So what I want to talk a little bit about is the just diversity of types of community science projects that are out there right now that you can become involved with. So this is just more of a smorgasbord. Right now there are different butterfly projects. They're looking at mosquitoes, a bunch of mosquito projects, from invasive mosquitoes to looking at disease vectors, whale sharks, okay, looking at the migration of whale sharks. How many of you know that here in New Hampshire we have an invasive earthworm? Yeah. Yeah, they're killing the forest. A lot of people don't know that, and a lot of it came through fishing and the import of these. So there's a project looking at earthworms, okay? Bunch of astronomy projects that are out there that I want to mention, from looking at, sometimes it's like crowdsourcing computer time too, because you need so many CPUs to study, where people, when they go to sleep, they donate their computer time to be working on these projects. Looking at microplastics and sand, and beaches. Okay, so you name it. One I'm going to talk about because I started mentioning this a little bit. Look at this graphic. You could have on your phone an app, eBird. Anybody have eBird on there? Okay, so eBird's a free thing. It's organized by Cornell University Ornithological School. And you know, I could go outside tonight here, and if I see those nighthawks, I could plug it in. Nighthawk seen, Concord, New Hampshire, on today's date. All that data gets assimilated, and what we're looking at here is, look across the bottom, April going now to June. We're looking at migration of birds, migration north, and now we're starting to see through fall, they're returned to the tropics. So all this data gets accumulated. There's another one called iNaturalist, which you go out, take a picture of a bug, flower, tree, put it, and it's mapping, okay, all these different species. Great project. I think a lot of elementary school students have been involved with Monarch Watch. How many people have heard of Monarch Watch? Okay, this is one where the migrating monarchs that we see right now, they're all winging their way. Hopefully they all make it to the central highlands of Mexico. And it's something where a lot of school groups this time of year will kind of live capture. Monarch butterflies have a little tiny tag you affix to their wings and release them. And researchers go down to the highlands and they look for these. They're color-coded. So New England's have certain, so you don't have to actually collect. You can say, these came from New Hampshire or New England. So it's a great project to get involved with, contribute to the data. Okay, and what I want to say is citizens, okay, there's lots that we do. We do sign petitions. If you're fortunate enough to donate money, great. Hopefully we all that are eligible vote. Okay, I can rally, march, write letters, make phone calls. Citizen science is where you go one step further. You're working in collaboration with others and a scientist or two, and you're developing some protocols, you're collecting some data, you're contributing online, okay, and communicating that. And just this was a list of a couple of discoveries that have recently been made and published. Birds are breeding earlier, climate is changing. There's a biologist at Boston University who published a book a couple of years ago. It's called Walden Warming. And what he did was he looked at Henry David Thoreau's field notes and the phenology of when things were happening in Walden back in the 1840s, 1850s, and taking a look, when do dogwoods bloom? And he was able to see that definitely, okay, we've got some climate change that's influenced the blooming period and the return of some bird species. The monarch butterflies. Nobody knew where these monarch butterflies were going. Leaving New Hampshire, where do they end up? Okay, and as it turns out, central Mexico and the highlands. I had to put this last one down too. Okay, one researcher was actually looking at the different types of bacteria that's found in your navel. And you want to know something that came out of that? I didn't put this on the slide, but it's true. They could tell whether or not you have a dog in your house or not, based on that assemblage of bacteria. Okay, so it's kind of interesting. Little CSI. Okay, and this part I'm not going to belabor, but I want to mention, this is, to me, I think what's really exciting. Can you still hear me? I'm sorry, I walked away. See? I did that. Take the microphone. Okay. What I'm trying to put is looking at, when you start a citizen science project, looking at the time from discoveries and impact that it has in society and policy. Citizen science, the research of looking at citizen science project shows that that usually occurs in 1 to 3 years, whereas just scientists alone in their labs can take 3 to 9 and oftentimes even over 9 to 10 years before it has an impact. So the importance of citizen science too, involving communities, is the quickness, the speed at which change and policy can occur. So yep, policy change slow, policy change quickly, getting the community out there. And then I want to put this in to say that I'm still involved in different projects. Some don't involve a lot of energy. Okay, so what you're looking at here is Aldo Leopold. Anybody ever hear of Aldo Leopold? Sand County Almanac? Okay, put him on your list. He was 20th century conservationist, and he had thousands and thousands of pages of field notes from the 1830s up into 1930s to 1949. In fact, so I'm working on 1,000 of those pages, little by little. So I'm a volunteer, and what I get are in blocks of 5 pages from his field notes. Okay, this one was from March 1948, and where I'm transcribing them. So there's a group of us that are volunteering this type of citizen science of making Word documents out of his, and the same thing. Okay, you notice each day he wrote about the phenology, what was happening at that point in time. So some of this we can glean looking at changes. Okay, since 1840s, what's happened, not just crickets changing, but when things bloom and when different birds would come. So there are different levels of energy and effort you could put into these projects. Okay, so here's the guts of it. SciStarter.com. It is a free website. They will never talk to you about money, never advertise, never put anything on your Facebook page or social media. This was started by Karen Cooper and some other researchers to really try to engage community people. You're looking at, so I signed up for it. I hope you can see we're on Dan Bisaccio, my page right here. And what you can do is once you sign up for it and get in, find a project. You can put a keyword or a topic. Okay, and then you can say online only. It's like my Aldo Leopold project that I'm doing, transcribing, or something near me. Find a project, and they come up. I mean, this summer, a lot of projects have been looking at tracking pollinators. Okay, so it's a great resource. If you know some teachers who might be interested in it, share that with them. You can put astronomy, mathematics, you name it. It's in there. And these, as I said, they don't take away your curriculum, but in fact, they could actually enhance your curriculum with it. So this I clipped earlier this week, this past Tuesday. I do get an email from them. It's not an advertisement or soliciting, but this email told me, I copied it into the slide. This Tuesday at 8:30, they're going to do SciStarter Live, and you could join and ask questions, so forth. Registration free. I put this up here because you can sign up anywhere. It started Tuesday, but it's ongoing. So if you go in, you can get the newsletter, and you can get some live help with any questions that you may have. Of course, one of the things I'm looking at, if you could read, is observing monarch butterflies that are migrating right now. Okay, so SciStarter.com, great resource, and this one involves money. Okay, if you're looking for some equipment, okay, this is an organization that will fund you. Okay, and so it's Youth Learning as Citizen Environmental Scientists grants. They offer grants a couple of times a year. So what's nice about this, it's usually, I think it's quarterly. So if you miss the deadline, you don't have to wait a full year. What I want to mention, places like the Discovery Center, Girl Scout groups, classrooms. Okay, it is really a very easy grant to put together. I did some volunteer work for a nature preserve around Port Jervis, New York, and they were looking to start some citizen science projects. So I wrote a grant, and we were funded, I think it was $1,500 for some initial equipment to get us started. I think the grants go as high as $10,000, but I think if you stay in the $1,000 to $5,000, you've got probably a better chance to get some seed money if you're looking for binoculars or some basic equipment. It's very low key. A lot of times people are intimidated by writing grants. This was basically write a couple essays. Describe what you plan on doing, what potential impact, who's going to be involved, what equipment do you need. It's a very simple application, so I really recommend this group. Okay, and even here at the Discovery Center. So once again, too, I could send you these slides or information about that. Okay, what I'm going to do is kind of zip ahead a little bit. So we've talked a lot of, oops, and get right here. I want to leave some time for questions. So that guy there on the left, William Waywell, it's about 1830, 1835, scientist, British, Royal Academy of Science. He was asking captains making voyages, whether they were Spanish crews, French, Portuguese, English, to collect tide data from wherever they were on this planet. And he began compiling, because nobody knew really about ocean tides and the impact around the globe. So he was working with this data, and he then asked a friend, Mary Somerville, to help him. She was getting a lot of respect for the work that she's a mathematician and astronomer, once again around the 1830s, and she was the first one to write a textbook on physical geography. So William Waywell, he didn't know how to describe her because at that time it was, you're a man of science. And here we have this brilliant polymath genius, a woman. And so he coined the term scientist and was first subscribed to Mary Somerville. So that's actually how scientists came about. Okay, so I wanted to mention that too because I thought it was very interesting. Karen is the one who's done the research on that. So once again, I just want to mention Citizen Science, great book. Buy the book. I mean, recommend it for teachers. Talks a little bit about the passion of teaching. And with that, what I want to do is just kind of formally end me kind of yakking at you and open it up to see if there are questions or comments. Or I'm going to put a student on the spot. Okay, I'm going to go right to Liz back there. Liz, do you have anything you want to say about your time in Mexico doing that HabitatNet work?
I mean, it was probably, I've been on a lot of cool trips, and it was probably one of the most memorable I've ever been on. Being able to, it's really still butterflies, I love it. And being able to practice projects, I mean, you really know wherever you are, and certainly led me towards becoming a science communicator and a science writer. Oh, I still have my Jaguar wall mat.
Okay. Oh, awesome.
It really sort of, the lessons that you learn for citizen science will stick with you forever.
So other questions or, yep, Chrissy?
So I know that you have done a lot of like individual research and your love of science and your love of birds. What is your most favorite adventure that you've been on? Like the last, as a scientist?
Wow. Let me think about that.
It was with me, right?
Yeah, just trying to keep up with Liz. Okay, that was enough of a challenge. Sometimes, okay, for me, actually, it occurred yesterday. I mean, each day I get excited about this. Yesterday, in my own backyard. Okay, I was actually jotting down some notes for tonight's talk, and all of a sudden I heard a flutter. And we had a sharp-shinned hawk show up on a tree about 10 feet away from me. Okay, and I got really excited. It was like, first time I saw one that close in our backyard. So the takeaway is, you can say, well, Dan doesn't take much to get him excited about anything. Okay, or, okay, I could say, there's a lot to get excited about out there, and you don't have to go to exotic places to find it. You know, there was a teacher in Jaffrey, New Hampshire, who several years ago told me that he was tagging monarch butterflies, and a researcher in central Mexico found one of the butterflies that they tagged and contacted him. Okay, so, I mean, to me, that was very exciting, you know, listening about that connection that he shared with his students. Sauhegan High School. One day, one of my students came into the senior seminar and he said there was a dead goose, a Canada goose on the road. A car had hit it. And so he said, Dan, do you want it? So I said, sure, bring it in. I thought, you know, we'd take a look at it before disposing. Well, the goose had a tag on it. And so we followed up and we found that that bird was tagged 6 years ago in the Chesapeake Bay. So it was really kind of cool. I mean, just those types of real connections and, you know, learning more about it, I think are very exciting.
I have a question here online.
Yep. Oh.
They said, where do you get the funding for programs like HabitatNet, and how do you advertise and get the word out?
Okay. So funding for HabitatNet back when I was doing it through the school was mostly self-funded for the going to Mexico. Okay, what we do is, since there was no ecotourism company or anything like that, we were able to keep it pretty inexpensive. And at the high school too, at that time, we also had some scholarship money for kids. During the summer, when I run with teachers usually find funding. Once again, it's also usually pretty inexpensive for professional development work, and some teachers found funding through their school systems to do it. But typically for a week in Mexico, I'll exclude the airfare because I have no idea what's going to happen with airfare. But usually the ground for about 7 days at the field site would be about $1,500. which included all meals, lodging, and all our transportation. So it's still an expense, but it's not as expensive as some others. I think for classroom projects, okay, you really don't need much to get started with these. And a lot of the equipment you can make yourself, okay, for the biodiversity work. I mean, if people contact me, I think they have my email. Whoops, yep, on top. I could certainly share with you, other than the YELSES group, you know, there are some other funding agencies that might take a little bit more work, but YELSES I found is really easy to work with, and it's great to get your seed project going with them. And I'm known as, I'll do the MacGyver science. A lot of the biodiversity equipment you can make from stuff you find around the house. Canopy densitometers, if you look in forestry catalogs, cost about $125 a piece. Okay, I make them out of toilet tissue tubes, the discarded ones, the little cardboard tubes and fishing line. So there are ways you can be creative about making the equipment that you need too. So good question though. Yep, Barb.
I have a question because I know that you were saying that some studies can take up to 8 to 10 years. So if you're a teacher and you want to sort of, you know, help your students, doing it 11 don't happen that long, what are techniques that you've used to sort of have them understand the value in being part of that long-term project, but just for the time you have it?
Yep, great question. I'll repeat it just in case somebody didn't hear it online. So some of the projects are long-term, 8, 9, 10 years. How do you, and you could see if I got your question correct, how do you keep kids excited or get them excited about it where they have those long-term? So I always look at it as when we went to a forest or whether here in our neighborhood, we're getting a snapshot in time. Okay, and that's all we're doing at that point. But over time, okay, that snapshot adds up and we can see change. So one of the ways in which I encourage kids is I think for any community science project, I would keep a group journal, classroom journal, that I wouldn't write it, the kids would write it. Okay, so I call these legacy journals. So for the biodiversity work, we've got this. So I know I should have brought some tonight if I knew some Sauhegan kids were here. I have 2 volumes from Sauhegan High School of kids' notes doing biodiversity work. And what would happen is whenever I would get to that project down at the reserve, I'd put those out. Kids would steal them right away, grab them, take them back, start reading them to see what their brothers, sisters wrote or friends in the past. So I think looking at journals and legacy journals that are associated with these projects are a great way to maintain some interest and get some humanness to the project as well. Yes, Bethany, right?
Are rocks and minerals connected to each other, or are they different?
Oh, okay. So we have a question about rocks and minerals, whether or not they're connected to each other. You have to, somebody who loves geology, this is great. So rocks are composed of minerals. So minerals are what make up many rocks. So here we are in the granite state. Okay, granite's the rock, and in that rock there are minerals like quartz and feldspar and mica. Okay?
It's found one that you said, okay.
Okay, good.
Did I answer your question?
Okay, good. Nice question. Any other questions from?
None have come through so far.
Okay. Yep.
Dan, how do we get this back in schools? How do we get these programs that, despite the cost, and you're sending a kid out of the country back in to keep making scientists?
Yep. I'd start really small and say not out of the country first, but what can you do right in your own schoolyard, backyard? And that's where I don't work for SciStarters. I don't get any kickbacks. But I really think, wherever that slide is now, well, I'm not gonna find it, sorry. I think looking at SciStarter and finding a project that fits in right now with your curriculum is where you get started and get excited. So, you know, one of the stories I wrote in my book was about, here's Dan, each year taking high school kids and they're flying to Cancun. How does the school board say okay to that? You know, it's a fair question. All right, and so I was very political. After my first trip, I had 8 kids. For my second year, which I wanted to continue this project, I actually invited a school board member to go on the trip. Okay, and let's say the trip cost $1,200. I actually charged him $2,400. And he was like, what? And I said, well, because that extra money is going to help fund some other kids. Okay, if you're an adult, you can pay for it, go ahead. So he went, okay, he philosophically agreed that was using that excess money to help some other kids. And he lived with the mosquitoes and mud as the rest of us, saw what we were doing, and he became the best ambassador for the program when we got back. So I think part of it too is just being politically savvy. I would say start small, get kids excited about projects at school. Once they're going home talking about it and parents talking about it, okay, and then I think you could develop it from there. I do think, simple as it sounds, I think these legacy journals make a difference too, of getting that. I mean, realistically, I would tell the kids, okay, and Liz, I don't know if you remember this, I would say these journals, you can write whatever you want, but I'm the ultimate editor. I said, if you put something in there that's inappropriate, I have every right to rip it out. Okay, and over the years, 10, 15 years of them doing it, I never had to rip out a page. Kids are always appropriate, it was funny. Usually each group, I was just going through it last week, rereading some of them. And a lot of the groups would put down famous quotes from the week in the jungle. Okay, and one of the students put down a quote from me. Dan said to ex-student, that's the first and last time you're going to pick up a snake. Okay. So, I mean, there a lot of humor that's injected in there, but also, you know, it kind of builds a history and also shows the importance that this is something, not a flash in the pan. I think now, too, with the pandemic and the fact that we've become much more fluent in using platforms such as Zoom, I would say don't hesitate to invite somebody into your classroom anymore, okay, if you don't have funding. I think my work when I was at Brown before I retired, many of my colleagues, and I certainly did too, I was Zooming into classrooms to talk about biodiversity. And you know, people will do it free, okay? And always, so I think getting kids involved with actual scientists, having discussions. An English teacher friend of mine was actually Zooming, her class was Zooming with an author of a book that they were reading. So I'd say, as a teacher, don't be bashful. You know, reach out, ask, and you know, I think there are ways to really get kids excited. So we had a Brown graduate student who was working in France on the Super Collider, the Hadron. Okay, and actually got him to Zoom into a physics class in Providence, a public school in Providence, talking to the kids and taking them for a tour of that. I mean, that was pretty exciting for the kids. So I think there are different things that we can do to really, you know, launch kids, you know, in science, mathematics, you know, different fields, getting them excited about it. Well, thank you very much for coming tonight. I want to thank the McAuliffe Discovery Center for coming here as well.
All right. Thank you, Dan, so much. I guess we're going to end the Zoom here for all of our friends that are virtual. I just want to say thank you, everyone, for coming on Zoom, and thank you all for being here tonight. So for all of us that are here in the building, in about 15 minutes or so, at like 8:15-ish, we're going to go into a planetarium show. One of our educators, Dave McDonald, he's going to bring us through what we can see in tonight's sky, which is very exciting. And then you might get a chance to see that actually outside tonight, because we'll have some telescopes set up, I believe, outside after the presentation to look at some of the things that we're going to learn. So thank you all so much for coming, and have a wonderful evening. Thank you again, Dan.
Feel free to use the restroom in the main. The planetarium theater is down the hallway. There's a big sign, planetarium down the hallway, turn left, and see you down there in 15 minutes.